Let's talk about classification of a heap. There are two kinds of heap, maximum heap and minimal heap. So the maximum heap is each node in the heap has a value no less than its child node. Therefore, the top element, which is the root node, has the largest value in the heap, and another one is the minimal heap, which is each node in the heap has a value no larger than its child node. Therefore, the top element, which is the root node, has the smallest value in the heap. Let's look at another example. In this tree, every parent node has a smaller value than its children. So this is an example of the minimal heap. However, this tree is not a complete binary tree because it doesn't meet the requirement that except possibly the last level, every level is completely filled and all nodes as far left as possible. While in this example, the node with value 7 is not as far left as possible on its level. A minimal heap is completely binary tree that satisfies the heap property for the minimal values. However, we should keep in mind that not all heaps are completely binary trees, as the definition of a heap is based on the parent-child relationship, which is the heap's property rather than the structure itself. So in this particular case, this tree is a minimal heap, but it is not a complete binary tree. Here is an example of a complete binary tree with 6 nodes, where each node's value is not larger than its child node, which makes it a minimal heap. So in this tree, every parent node has a smaller value than its children, so it is a completely binary tree, as every level is completely filled except the last one, but all nodes are as far left as possible. In the first example, is this tree a heap? Yes, it is. This is a complete binary tree, and the value of each node is not larger than its child nodes, so it is a minimal heap. 1 is less than its child node 2, and 3 is less than its child node 4, and 2 is less than its child node 6, so this is a minimal heap. In the second example, although this is a complete binary tree, it is not a heap because not all nodes have equal or larger or equal or smaller values than its child node, so they lack of consistency. For instance, the node in the first row, which is 8, which is larger than its child nodes, which is 3 and 2, while the left node in the second row, which is 3, has a small value than its child nodes, which is 4 and 5, so we cannot make sure whether it is a minimal heap or maximum heap, so this tree is not a heap. In the third example, although this is a complete binary tree, it is not a heap because not all nodes has equal or larger or equal or smaller values than its child node. Let's take the second row as an example. The node with value 3 is smaller than its child nodes 4 and 5, while the node with value 6 is larger than its left child 2.